What is going on, guys? It's Modded Warfare here and welcome back to another computer tutorial. So in this tutorial I'm going to be showing you guys how to bypass different kinds of login systems. Now this is not done for any malicious purposes. The reason is kind of from a developer standpoint to show you guys what is secure and what's not secure when it comes to creating a secure login system. So yeah, something that I got confused with when I first got into coding and I tried to create login systems to protect something, and I'd watch a video tutorial on how to create a login system, I'd create it, it would work, that's great, and then I'd find out later on that it was completely unsecure and had loads of security loopholes. So that's the idea behind this video, to show you guys how to bypass certain login systems so you know what areas to secure when you make your own login systems, or if you're new to coding and you're wanting to make to secure an application, then you'll be able to know what areas you need to protect. Essentially, that's mainly the idea behind this video. So I've got a bunch of tools here which can be very useful if you're a developer for protecting your applications, for checking for security exploits in your application. And I've got a bunch of login systems here going from a really weak, poor security all the way to good security. Now the one thing we're not going to be going over in this video is decompiling. That's not what this video is about. Obviously, you can decompile an application into its source code and remove the login check completely, but as long as you use good obfuscation and other techniques to prevent that, then that won't happen. But that's not really a login specific problem. It's a problem relating to pretty much anything coded in .NET. And this video is not specific to .NET either, which is why I don't want to really go over decompiling that much. So just as an example, you'll see that, obviously I can't go ahead and open up a shortcut, but if I open file location, drag this in, you'll see that the file does not contain a managed assembly. So you can't decompile it, and even if that's because it's packed, and even if you unpacked it, this is the unpacked version, you can see that basically it's completely obfuscated, so you're not going to be able to get any source code from these applications. So we have to try and bypass the login in a different way other than decompiling it. So first login system we have right here, so go ahead and open it up. Don't know what the username or password is, I can't log in. So first thing we do is we open up Wireshark Legacy. Again, all the links for this stuff will be in the description. I just use the legacy version because I feel it's easier to use. I'm going to select my adapter and start a packet capture. So I'm going to reopen the tool and try and log in again and see what network packets, what kind of protocol it's using. So we'll click login, and boom, we get a bunch of data showing up here, a bunch of packet data. And we can see that there's a lot of FTP and TCP packets, so looks like this is using an FTP login. So what I can do is I can filter for FTP traffic by just entering FTP and apply, and that will only show the FTP packets. And as you can see, we've got file transfer protocol, and we're using username as Xbox, password is Xbox, and we've got the destination, which is the IP address that the FTP server has been hosted on, which is 192.168.137.232. So that's where it's hosted on. Obviously, all the servers that these login systems are using are local, but in a real world scenario they'd be on a public server with a public IP, but again, it makes no difference for this tutorial. So yeah, we basically got access, and the reason that this is so unsecure is that the username and password of the FTP server are actually stored in plain text in the packet data, so you can easily just capture it and find out exactly what the username and password is to log on to the FTP server, and you can see what directory it's reading from, where it's reading the login accounts from. It's reading them from hdd1/login. So what I can do is I can basically just log into this FTP server and create a new account, or find out what the account name is, or even destroy the server and delete all the files inside it if it has write access. So I can log in using FileZilla with 192.168.137.232 because we have the server address from Wireshark, and we also have the username being Xbox, the password being Xbox. As for the port, it's probably going to be 21 because that's usually what it is for FTP, but if it was something different, I could just double click and find out the destination port, which is 21 right here, and from there I can type in 21 and connect. And the reason the username and password is Xbox is because it's my Xbox 360 that's hosting this FTP server. So it was in HDD1 and then login, as we saw here. And there we go, admin and testing. So username admin, password testing, or maybe username testing, password admin. But either way, we have the login information to log in, and login successful. So we bypassed that one really easily. And yeah, not a good idea to be using an FTP server, because, you know, if you can access the server and completely screw it over. So it's very, very unsecure to be using an FTP, as the username and password are just stored in plain text. I think most people would know that anyway, that it's not a good idea to use an open FTP connection for a login system for authentication. So moving on to the next one. So we can go ahead, do the same thing, use Wireshark, go ahead and capture on my local area network, and we'll type in some information, click login, and boom, we get a bunch of information here. Login unsuccessful, invalid credentials. Thought there was a problem with the server there because it was taking so long, but it has tried to log in and failed. And this time you can see there's a bunch of MySQL packets. So it's using MySQL. I can filter for MySQL, so it'll only show those MySQL packets. But this time, this looks a bit more secure because, I mean, I'm not sure if it's stored in plain text anywhere. It doesn't look like it is because, you know, I'm not seeing any. I mean, there is plain text here, but I don't see the username or password. Oh, is that it there? Hold on. No, it's not. That's just the name of the virtual machine it's running on. So no, it doesn't look like we can get the username and password in plain text like we can with the FTP server. So it is more secure than the FTP because we can't see the username and password, but it is still unsecure because it's using MySQL. It still has to send the username and password of the SQL server to the server from, you know, your local machine to the server in order for it to log into the server to check the database and see if the login information is correct or not. The problem with this is that the username and password must be hard-coded into the application. So the username and password must be in the application somewhere, as a string probably in the application. Now the problem with doing that is that it's very unsecure, and the reason it's unsecure is that you can get strings from memory. When you run the program and you try and log in, all the strings are loaded into your system's RAM, your system's memory, and then you can go ahead and just grab all the strings from memory using a program like Process Hacker. So this is Process Hacker 2, again, link will be in the description. What I can do is I can try and log in to make sure that all the strings get loaded into memory. And for example here, this string here, login failed, I mean that's a string, so that'll be loaded into memory. So if I right click on the application in Process Hacker, go to Properties, go to Memory, click Strings and OK, and that'll grab all the strings in the application. And then I can filter for a specific string. So if I search for login failed, then I get login failed invalid credentials. That was loaded into memory, which is the message I get when I try and log in. So I can also search for, say, the IP address, which we found here, 192.168.1.79. I know that's the IP. This one's my computer. I know the IP of my own computer is 1.64, so this one's hosting the server 1.79. So I can search for that in the strings 192.168.1.79 and search, and you can see we have host 192.168.1.79, username Lee, password testing123, database equals modded warfare. So we've got access to the database. We've got the username and we've got the password and the database that it's connecting to. And that's the problem with having your database information stored in the application itself as a string in the application. So one way you could protect this is to make sure you obfuscate and encrypt the strings on your application, which a lot of people forget to do when they're protecting their application. They forget to obfuscate the strings or encrypt the strings. Very important you do that, especially if you have database information stored in your application like this, because we've basically got access to it now. We could log into it, we could use a website scanner on this address to see if it has something like, you know, my web SQL or PHP my admin or something on there that we could use to log in using this username or password, or through PuTTY or something like that we could log in. So yeah, definitely not a good idea to have that, to have it stored, to have your database information stored in the source code of the application like that. So yeah, definitely not secure. So moving on to the next login system, third one down, we have this one here. So I can try and log in. Login failed, invalid credentials. Very similar, so let's go ahead and check what's going on in the packet data here. So we'll clear, we'll start a new packet capture and log in, and boom, we get a bunch of what looks like SSH traffic. So that's secure socket layer encrypted traffic, secure shell. So we can filter for SSH. Oops, needs to be lowercase. Apply, and that grabs all the packets on SSH. And if you know what the server is and you're not sure what protocol, then you can also filter for the server address by doing ip.addr equals 192.168.1.79 or whatever the server address is, and you can get all the packet data from the IP address that you search. So as you can see there, it's using SSH secure socket layer, so that means that all the packets are fully encrypted and there's no way we're going to get any information from them. And if you double click one of these packets, you're not going to see any plain text. It's all jumbled up, encrypted data. So there's no way we're going to get any information from this. So it would seem to be quite secure, especially if it's fully obfuscated. However, it suffers from the same problem as the SQL one, because the simple fact is that it has to send the server information, the username and password of the server, to the server in order to log into it to check to see if the username or password is correct. So that again is another vulnerability. So all we have to do, make sure we log in so that all the strings are loaded into RAM. We can right click, go to properties, head to memory, strings, and once again search for the IP address. Now obviously the IP may not be hard coded into the application. It might use a domain name instead, but even if it uses a domain name, you'll still find the packet data from the IP, and then you can double click and it will give you the domain name in the strings. So, you know, even if it's using a domain name, you can still find the domain name from Wireshark, and then, you know, from there you can type in the domain name if the domain name's added as a string instead of the IP. So we'll search for the IP here, 192.168.1.79, and there it is. Got a bunch of them in here. Doesn't look like the password or username's in here. However, if you look a bit closer and double click, you can see we've got the address, we've got a username, James, and we've got a password, testing123. So even though it's using encrypted data packets, we can still find the username and password to the server in the strings. Now, because it's using SSH, it's either going to be using some kind of direct connection, like some kind of SQL login, or it's going to be using secure FTP. So you could find out by just trying to log in through PuTTY, and if you can't log in through PuTTY, then it's probably using secure FTP. Obviously I coded it, so I know it's using secure FTP. So I could create a new site, so open the site manager in FileZilla, create new site, select something like, I don't know, SFTP for secure FTP, and put in the server address. The port is going to be 22 because we can tell from Wireshark it's using secure socket layer, which is port 22, and you can also double click and look at the destination port, or the source port, which is 22 right here. So we know that it's using port 22. File transfer protocol, change that to secure file transfer protocol or SSH file transfer protocol. And then login type was James that we found from the strings, and testing123 for the password. Click OK, and then from the drop down list we can select SFTP, and that connects to the server, and in there we can go to the www directory because that's the only directory in there. But even if we didn't know what directory it was in, I've already closed that. Well, it was in the hex as well. Above the IP was the directory, which was www, and there we've got admin and testing. Same password as the other FTP login, but there we go, we've gained access to it right there, and we could add a new account. We know what the account information is, so we can log in. Testing, log in successful, so we bypassed that one. And yeah, we could add a new user account or delete the user accounts, do whatever we want now that we have access to the server. So there you go, even though it's using secure socket layer encrypted data and it's fully obfuscated, well, apart from the strings, it's not secure because the strings weren't protected properly. Okay, so now we come down to the next one right here, second last one. So this one is actually a lot more secure, although I have left it vulnerable to a particular type of exploit that I'm going to be showing you. So let's go ahead and do the same thing. First thing we would do, we'd clear this, start a new packet capture, try and log in. Boom, we get packet data right there, and you can see the data that we've got is TCP and HTTP. So there's a text/HTML, so it's sending some kind of response back to the application. And it looks like the response is false. So it's sending false back to the application. So what we can take away from this, and the difference between this, and you could see when I logged in there, only 3 packets were returned. So every other login we've done so far, there's been tons of packet data that showed up. With this, there's only 3. So yeah, what's actually going on here is the fact that this login works a lot differently. What it does is when you click login, is it just sends the username and password that you type in, just these 2 boxes, what you type into these 2 boxes, and it sends that to a PHP page on the server, and that PHP page then interrogates the database, which is hosted on the same server. So it interrogates the database, finds out whether the username and password that was sent to it from this application is correct, and if it is correct, it sends us a particular response back. If it's not correct, it sends a different response back, and then this application interprets that response as a successful login or an unsuccessful login. And that's a lot more secure because we're not actually sending the connection to the database, the actual username and password of the database itself to log into the database. We're not actually sending that. It's not hard-coded in the application, and we're not sending it across the network to the server. It's already on the server. All we're doing is sending this information, the username and password that you type in. We're sending that up to the server, and then the server's doing all the work. And because it's PHP, all that code is server-sided and we can't access it. So that's a lot more secure. We're not going to be able to get access to the database. However, like I said, I did still leave this vulnerable to a different type of exploit, and that exploit is packet injecting. And I've left it vulnerable to packet injecting so I can show you this. So in order to do packet injecting or explain how it works, we're going to go ahead and open Fiddler 2, which allows us to packet inject. And what Fiddler basically does is it forces your programs and other network activity or other programs on your system, it forces them to run through a proxy server. And what it can then do is it can pause the packet data and allow you to edit what's in the packets before the packets are sent back to their destination. So what can that allow us to do? Well, let's have a look. If I just enter some information, I'm not going to make it capture anything right now. I'm not going to make it pause any packets. So we're going to go ahead and log in. Login failed. And what we can do is we can go ahead and look at the text view, and that gives us the response that the server is sending back. And you can see it's just sending back the word false, which is that must be the response for an incorrect login. So it will return false if login is unsuccessful, and it'll probably return true if the login is successful. Or on another system it might use 1 or 0, 1 for a successful login, 0 for failed login, or a string, maybe a certain string for successful login, a different string for an incorrect login. So what we can do is we can packet inject this by going to rules, automatic breakpoints after responses, and that will just pause the packet data that's sent back from the server, not the data that's been sent to the server. And then we can click login, and this time you see the program's frozen. And the reason it's frozen is because it's waiting. See it not responding there? Still waiting to get the response back from the server. So it's waiting for the server response. Now what I can do is I can click the packet and I can edit the information inside, change false to true to make the program think that the login was successful, and then click run to completion, which will send the packets back to the program. and therefore it thinks that the login was correct, and it gives me access and lets me into the system, gives me full access to the system, because even though the login is wrong and the server knew it was wrong and sent back a response to say the login is wrong, I manipulated that response before it got back to the program and said, no, actually the login is correct, and the program took that and thought that it was correct and let me access it. So yeah, you got to protect from packet injecting as well when you're making login systems. So the last one I want to show you is secure. I mean, I say secure, it's not the most secure. I would add some more protection to this if I was going to actually use this in a real world situation. So anyway, here we go. So same thing as before. This time what I'll do is I'll go rules, automatic breakpoints disabled, and so that we can't see. So what we'll do is we'll go ahead and, okay, so here we go. So we can click login, failed to log in, and you can see this is the response that's sent back. It's encrypted. So okay, that's no big deal. I mean, if you find out what the correct login is, then you can spoof this with the correct login encrypted response. However, if I log in again, you'll see that this one's different to this one. Each time you click login, it's different. The response is different, which makes it impossible to packet inject, because how do you know what the correct response is when it's different each time? It's kind of impossible. And not only that, but if I do try and actually packet inject, and by pausing the packets, and I don't even change anything, and I just run it to completion, you'll see I get an error message that says login failed, packet injecting detected, and that's because there's some various different protections on there to prevent packet injecting. One of them obviously is making the response different each time, and the other thing you can do, which I just did there, is I made it so that the application checks how long it takes to get the response back from the server. If it takes any longer than a couple of seconds, then that's not right. It should get the response pretty much instantly, and if it doesn't get the response instantly, then it assumes that somebody's trying to packet inject it by holding the packets so that they can be edited. So yeah, that is basically it. It's pretty damn secure compared to that, and obviously what can I do? Yeah, I can show you the strings of this as well to show you that it's protected. So if I enter some information, log in, so that the strings are loaded into RAM. Whoops, I forgot that this is going to run that to completion. So what we can do is we can find login properties. So you can click on strings and grab the strings, and as you can see, if I go further down, you can see all these strings are completely screwed up. I mean, look at that, that's all completely screwed up, and that's because the strings are encoded and encrypted. However, I must stress that even if the strings are encoded and encrypted, some of them get decoded and unencrypted once they're loaded into RAM in certain situations. So even with string encryption and string obfuscation, they can still be found in Process Hacker, which is why it's very important that you don't use one of those login systems, one of those three that actually has your username and password for the server as a string in the source code of the application. So anyway guys, I hope that helped you in some way, or you found that information useful. Hope it helped somebody anyway, because yeah, it's a bit of a random video, but anyway, hope you guys enjoyed. If you did, go ahead and leave a like, subscribe if you haven't subscribed already, comment if you have any questions. Hopefully it helped out somebody who's, you know, looking into creating a more secure login, or if you already have a system out there that's that's vulnerable to one of these things, you can now patch it and protect it better. So anyway, hope you guys enjoyed. Go ahead and leave a like if you did, subscribe if you haven't subscribed already, comment if you have any questions, and I'll hopefully see you guys in the next video.